Tusen takk til deg, Tommy og Lars. Det er jo veldig ordentlig å høre at det ikke alltid er så skummelt å bytte fra noe man kjenner til noe man ikke kjenner. Men nå skal vi gå litt bort fra CRM for denne gang, for nå skal vi snakke om et tema som jeg vet at du, Eirik, er veldig opptatt av.
Ja.
Og det er kunstig intelligens, artificial intelligence, og kanskje helst det at folk er litt redd for det.
Ja, altså, det er jo litt fascinerende hvordan vi lar oss kanskje skremme litt av ting som vi ikke helt forstår. Og det er jo ikke noe rart at man synes at kunstig intelligens kan være litt uhåndgripelig. Faktum er at vi har jo holdt på med kunstig intelligens siden 50-tallet. Så det er ikke noen ny greie. Og en ting vi bruker kunstig intelligens mye til er for eksempel i roboter. Og da blir man også redd for roboter. Vi er veldig preget av liksom, popkulturen og science fiction og tanken om hvor skummelt dette kan være. Da. Jeg traff en fyr etter at jeg hadde holdt et foredrag om teknologi og digitalisering og roboter og kunstig intelligens. Tipper på han var sånn slutten av 50-åra, begynnelsen av 60-åra. Administrerende direktør var han. Han sa at det var veldig spennende det jeg snakket om, men sånn kunstig intelligens og roboter, det må vi være litt forsiktige med. Og så spurte jeg, hvorfor det? Hva da? Husk på hvordan det gikk i Terminator. Men det er ikke tull. Altså, hans referanseramme, og han er ikke unik, er ofte ting man har sett og lest i filmer, og så blir man redd for det. Men når de plutselig begynner å gjøre ting vi ikke er redd for, som vi synes er litt kjedelig til og med, som vi forstår, da er vi ikke så redd for det. Sånn som, har du robotstøvsuger?
Ja, selvfølgelig.
Ja. Hva heter den?
Tore 2.
Ja, og Tore 1 her.
Nei, det er jo ektemannen min selvfølgelig, fordi at jeg hater jo støvsuge, så da må jo noen andre gjøre den jobben. Da har vi Tore 1, og når Tore 1 ikke kan, for han skal jo jobbe med litt annet også,
ja, han må ta oppvasken.
Da trår Tore 2 til.
Ja, det er, ikke sant, og de får navn. Jeg snakket med en kar som jobbet i Jernia. Det var også et foredrag jeg hadde holdt, og der kom det inn en som hadde kjøpt en robotgressklipper, som hadde gått i stykker for 3 måneder siden. Den var ikke gått i stykker. Han hadde kjøpt den for 3 måneder siden, hadde gått i stykker nå. Kom og leverte den, hadde kvittering. Han hos Jernia sier at det er jo ikke noe problem, da kan du jo bare, det går jo på garantien, kan få ny. Kan du ikke reparere, Truls? Han var glad, han ville ha den. Ja. Og sånn er det jo med veldig, så det er veldig myteomspunnet mye av dette, men man kan bruke det også til fantastiske ting, og det er jo det vi skal få høre om nå. Jeg pleier også å anbefale en bok. Jeg har en professor fra MIT, Dr. Kate Darling, det er jo et nydelig navn hvis jeg har sett, Dr. Darling, skrevet en bok som heter The New Breed. Den handler om kunstig intelligens og roboter, og at vi ikke skal være redde for dem. Den anbefaler jeg alle å lese faktisk. Men nå skal vi høre noe annet.
Nå er det Ruter.
Ja, og nå må vi også si fra om at chatten, følg med i chatten, for der er neste foredragsholder til stede og kan svare på spørsmål hvis dere har det underveis.
Ja, for nå skal vi da, vi har vært så heldige at vi har fått med oss Umer, imam fra Ruter. Og han skal snakke om hvordan de har brukt kunstig intelligens på en mer sånn praktisk måte, hvor man både har klart å forbedre kundeopplevelsen, og også opplevelsen til de som sitter i kundesenteret. Og som Eirik sier, så er det sånn at han er med oss under foredraget her, så hvis dere har noen spørsmål underveis, så er det bare å stille det, og så kommer han til å svare i chatten. Men da setter jeg bare ordet videre til Umer.
So my name is Umer. I'm the head of artificial intelligence, data science and data warehouse at Ruter. I'm also an assistant professor at Oslo Met and I teach artificial intelligence. And I am also the founder and CTO for Binaric, which is a data labeling company for AI applications. Today we are here to talk about the use case in Ruter, how we use artificial intelligence to increase our customer experience. And also to create an AI agent which reduce a lot of load from our customer service department. So for those of you who don't know what Ruter is a transport company and it's based in Oslo and it provides transport services to Oslo and Viken area. At any given time we have almost 1 million boardings and we sell around 150,000 tickets every day. If you take a look at the graph, there's a lot of development since 2008. We have seen very nice growth, exponential growth, and you all know what happened in 2020. And there was a huge drop, and then we lost a lot of users. which is fine because a lot of industries suffer at that point, and we're trying to get back into the phase where we get our users back and we become more of a growth company. The focus of Ruter has always been like customer focused. We provide services to our users, our customers, and we want users we want them to be happy. But sometimes things go wrong. And when things do go wrong, we get these kind of headlines in the newspapers. And when you get these kind of headlines, it's not really nice for us being an authentic company or being a company which is focused on the customers. And all of a sudden, the newspapers are full of these headlines. So we started looking into this problem. We were like, how can we stop this from happening? How can we stop from getting bad reputation in the media? How can we stop this from happening that our customers are not unhappy with us anymore? If we look at the timeline of events and try to identify what went wrong, the timeline is very simple. A customer has a problem and they send an email to our Ruter's customer service. Ruter's customer service looks at the complaint, tries to resolve the issues, and everything is fine. The customer is happy. But in an alternate series of events, the customer sends a complaint, and for some reason, our customer service was not able to resolve the matter in time. And that problem impacts more than one customer, and there are more customers complaining about the same problem. And what happens is when that happens, that problem starts getting more attention, and then it comes into the media. Then journalists start taking interest in that story. It comes in the media, the anger boils over, and our customers start giving us they start talking about bad things about our organization online. And we also get bad feedback or bad reviews on our apps from our users. So then we saw this happening, and we were like, how can we stop this from happening? And the goal was, how can we use artificial intelligence to identify a problem before it becomes as big as we have identified now? So that was the goal. And when we started thinking about it, we were like, okay, let's look at the data we have. And where is this data coming from? This data was coming from the customer services system. And this system was like the system we use in Ruter is called Siebel. And what happens is when a customer sends in a complaint comes in, it gets registered over there, and then we store it in a storage. And this was the data we wanted to look at, not the Siebel system. We wanted to look at the data of all the customer complaints, and then we wanted to use artificial intelligence to transform the data. So that was the goal. And there are multiple steps involved in this AI project, right? So now we had the data. What we wanted to do was we wanted to in a very basic way, try to analyze how angry our customers were. And this in artificial intelligence is called sentiment analysis. So if you are a customer of Ruter, and you send us a complaint to us, we already know that you are somewhat angry at us. But by looking at the type of the complaint, we are able to identify if we are very angry or if you are somewhat angry with us. So that's what we did with AI. So the slide you see in front of you, you see different variations of colors. You have people, so we use sentiment analysis to all the data, and then we identified people or complaints which were mild, people who were mild angry, which were most angry, and people who were extremely angry with us. And every color in this slide kind of shows you the emotion of that person. And we used this data, right? We used this data and then we mapped it on the map of Oslo and Viken. And that gave us very useful insights because now we were able to see exactly in which stops people were most angry at. And based on that information, we were able to focus our attention on solving those problematic areas. That was step one. The step two was opening up the data. Now, even though I'm an employee at Ruter, there's certain type of data which I don't have access to, and that is because we have a huge focus on customer privacy. When users send us complaint, they write about all sorts of issues. They talk about their their phone number, their account number, their social security number, and sometimes they also expose their health-related issues. And being an employee at Ruter and not being part of the customer services department, I'm not allowed to look at that information because we have a huge focus from Data til Sine that this information should be secure. So in an organization of 500 people, only 20 people were allowed to access that data, and that's it. So our goal was to open this data up. I mean, if you're talking about Ruter being a data-driven organization and only 20 people can access it, there's something wrong, right? So what we did was we used an anonymization algorithm and we hid all that sensitive data. So in front of you, you see like a lot of data, which is about account number, phone number, email addresses, name, that was hidden. This was a breakthrough for us because what we were able to do was we were able to open up access to this data from 20 people to 500 people. And today, everyone in Ruter has access to this data, and they use this data on a daily basis to generate their insights. I have to say that our law department does not agree that the data is 100% anonymized, but that's just because that's a discussion between the technical teams who think data is anonymized and the law department which says like, we can do a better job at it. Then step number 3, we wanted, and that's where the power of AI actually comes out, and that's how can you identify hidden trends in your data by using artificial intelligence. So if you look at the screen in front of you, you will see that the image shows different colors and different colors of different colors marked in various shapes. So what you see in front of you is actually all the complaints we had. So we took all of the complaints, we gave it to an AI algorithm, and what the algorithm did was it categorized the complaints based, so it looked for the pattern of what people were talking about in the complaints. And when it saw like similar people were talking about the same problems, it put the complaints together, and that's how we identified that, all right, so in front of you, the color pink shows people talking about one problem. The red color shows people talking about one problem. Yellow color shows people talking about the same problem. And that's the power of AI, because AI can group huge text of data in one classification. And if we were to do that, it will take a lot of time for humans to do similar operation. Now, what was useful for us in this operation was that we were able to identify new classifications in the data. For example, we identified that people were talking about congestion inside the bus. We knew some people had this problem, but we didn't realize a lot of people were having this problem. Then people were talking about bus drivers having bad taste in music, and that could come probably because either the bus driver himself, either the bus driver themselves had bad taste in music, or the music was too loud inside the bus. And the third problem was that the buses were not wheelchair accessible. And these were new categories for us. So if you go to contact.ruter.no, we made these 3 categories by default available for users. So now they can pre-select them, and they can write about their complaints. The 4th step was the visualization part, and this visualization part was something we did so until now, all the processes we did, we cleaned our data, we used AI to enhance our data. And when that enhancements were done, we were like, how can we show it to the end user? And that was the visualization part. So in front of you, if you see like this screen in front of you, they're like on the right hand side, you have a map. You can zoom in and zoom out in the map. And as soon as you zoom in and zoom out, the left-hand side will automatically update. And left-hand side shows you how many cases we had. Another version of the screen where on the left-hand side, you have the map now. So when you zoom in and zoom out, you have these big circles which show you how many complaints have come in on that specific area. When you click on a circle, on the right-hand side, then you will see the actual complaints coming up. And the whole system is very interactive. So you zoom in and zoom out. On the right-hand side, you click on the complaint. It will automatically update the banner, which is all the way down, and so forth. On this page, what happens is, it is also an enhancement of the previous one. It's again on the bottom you have the complaints coming up, but on the left-hand side you can actually do a free text search. So if you working inside Ruter want to see how many buses had a high temperature, you can just go on the free text search, write warm, and then all of the complaints related to them, the buses being warm will pop up. On this side and the one forward, we implemented the sentiment analysis part. So what you can see on this slide is that on the map, the red area shows people who are extremely angry. The green area shows people who are happy with our services. And then you can click on a specific route. For example, over here we picked up the route number 100. And in the route number 100, you can actually see the path of the bus at a specific time of the day. And then you can see at what interval and where exactly people were most angry or they were happy with our services. And you can click on that specific area and you'll see all the complaints coming down over there as well on that specific instant. This screen is also another extension for the previous one, where it gives more power to the end user to get more insights about a specific route, a specific stop number, and a specific stop name. A few dashboards just to give you more information for our end users, how they can see if there's some problem on a specific day. And then this last screen I wanted to show about is something we are working on right now. Like right now, the data we had was coming from our internal support system, but we wanted to combine it with our social media data as well. We're not done with this yet, but we want to integrate more data into our system. Summary of this project. So this project was hugely successful inside Ruter. It's being used today by almost 200 people on any given day. These reports are being used by 200 people on any given day. The cost for the project was also very interesting. Like we got help from 4 students. They helped us create this project, and it cost us 150,000 kroner, and it was done in a very small time of 1.5 months. So the time and the cost invested in the project and the value which we got back was just amazing. And this project is also considered one of the success stories for our organization. By this time, we had a lot of data which we had transformed using artificial intelligence, and we had a system of insight built on top of that one. We started to think like, what can we do more with this data? And the answer was pretty obvious. We were like, if we know what the customers are talking about, we know that the customers have a problem, and our systems are intelligent enough that they can understand this problem. Because the problem we had right now was that a lot of people, when they were sending us complaints, the first problem was we didn't have insights on the data. So this problem was checked. The second problem was, like if you are a user of Ruter services and you are standing on bus, you're taking the bus number 20, you're standing at stop Hellsfield, and you've been waiting and waiting and waiting, and the bus didn't come. And you're frustrated, and you open up contact Ruter and you send us a complaint to us. Now, by the time we follow up on the complaint, because the bus will come, right? The bus is probably a few minutes late, but you are frustrated as a user, and you send us a complaint, and by the time someone follows up from Ruter, because we get a lot of complaints, and we have to follow up all the complaints as the order they came in. By the time we follow up, the context of the problem is already over. You have already taken another mode of transport, and you are on your way. Now, the second goal we had was, how can we automate this process so as soon as the user sends us a complaint, we can automatically reply and make sure that the user has the information. And that was where the idea of the AI agent came in. Now, until now, we know what our users were talking about. We knew that they had a problem. We knew that this problem had what kind of context it was, how angry they were, where they were standing at, and what kind of classification we're talking about. Now, the only thing remaining was, can the agent also reply to this email? And the answer was very simple: yes, the agent can do that. Now, when we looked at our complaints, almost 7% of the complaints we get today are related to the bus either being cancelled, the bus either being late, or the bus arrived a bit early. And we were like, this is an easy thing to automate. Like if there are 7% complaints coming in only about where is my bus, when will my bus come, and all the time customer service kind of rewrite the same thing and send it back to the user, this is an easy thing to automate using an AI agent. So that's what we did. And that was the game, that was the goal, make an AI agent which kind of automatically replies to all incoming inquiries. Like any other AI algorithms, when you start writing an AI algorithm, the first thing you do with an AI algorithm is that you want the algorithm to predict like a human. And that's the first goal you do. So if you look at stock market prediction algorithms, that's what they do. If you want to see what kind of temperature will be tomorrow, day after tomorrow, if an AI is used, AI will always predict, because that's the goal of AI. And that's what we also did. We wanted the AI agent to predict or as close to the human as possible. So in front of you, you have examples of the predictions which our algorithm did right and the predictions which the algorithm did wrong. So this is an example of the predictions which the algorithm got right. And it clearly predicted that the customer was talking about the bus being cancelled, or the bus which came very late. And it looked at the problem, the algorithm looked at the problem, and it understood what the user was talking about. But of course, we also got wrong predictions. And if you look at this text will show you what kind of wrong predictions we got. And if we as humans read this whole sentence, we will understand that the person over here was not talking about one problem. The person was talking about 2 or 3 different problems. But since we are intelligent beings, we can, by looking at this text, we can determine that the person at the bus, that the bus was not even supposed to run on that route. But the algorithm, based on its limited information, concluded that the bus will be delayed. And that was a wrong prediction. So that's an example of what we learned. Anyway, when we ran our algorithm and we did all the predictions and the output came out, it turned out that our algorithm was doing 89% good predictions and 11% predictions were wrong. And that was all right, because in an AI algorithm, 85% to 89% is a pretty good prediction rate. And most of the companies are okay with that kind of benchmark. And we were fine with that. We were like, okay, we understand that our algorithm is doing 11% wrong predictions, but it's not a disaster situation for us. Once we tested the algorithm and we saw that it was doing good enough predictions, we deployed it to production. We went live with the algorithm. And what happens, yeah. So if you see in the screen in front of you, so I don't have anything to show you how the algorithm works, because the way you can test out the algorithm is you go to contact.ruter.no, you put in your complaint, and if your complaint is regarding the bus being late or cancelled or delayed, chances are that your question will be answered through an AI agent. And how can you test that? It's all based on the time. So what we tested internally was that if a question comes in, and the whole time it takes for the question to be answered by the AI agents, it's a matter of milliseconds to as long as seconds. In our test, it took like 10 seconds for the agent to respond. And for us, that was a huge jump, because it not only decreased the load on our customer service, but it also ensured that our customers had the correct information at the right time. This project, just to talk about the summary for this project was also done in a record time of 1.5 months. It also cost 150,000 kroner, and we did an analysis on how much cost saving has it, since this was done in 2020, right? Has it been useful for us or not? And what we found was that this agent has replaced a full human working inside the organization. And if you put that into perspective of how many hours a person works and how much communication they require with other people, the actual amount saved is actually much higher. So right now we think it has helped us by replacing one human inside the organization. So that was customer insights and the AI agent using artificial intelligence inside Ruter. So the question is, what's next? Where do we go from here? Or what are the projects we are going to work with in future? Now these projects were done in 2020 and they are so mature that you probably remember the Ruter app, which was launched some while back. And we initially received a few complaints from our end users. This customer insights project, this was very useful for us because what we started to do was we started looking into all the complaints coming in from the users, and we put our development team to look at those complaints, and we did like an iteration development on the app. So we saw what the users were complaining about, and we improved our app based on those complaints. So this reporting tool was very useful to us. On the other hand, the AI agent has been useful to us because people who have been asking us about similar questions, the bus being delayed, canceled, or not being on time, we were able to automatically answer them, thereby increasing customer satisfaction of our users. Now, there's a third area which we are looking at. This project has not been approved yet, but we are thinking about it. And what is that? You probably heard about fraud, and there was an article which came out on 14th of February 2022. There was a person who frauded a lot of organizations for approximately 11.7 million kroner. And that person was so smart enough that that person was able to defraud 150 organizations. So if it happens with one company, two companies, three companies, that's a specific case, right? But if it happens with 150 companies, there's a trend. There's a trend, and the person identified that trend and used that trend to his advantage and was able to defraud the companies for around 11.7 million kroner. Now, in a country like Norway, it's pretty big, and it impacts a lot of different companies because we are a small country. So Ruter has been thinking about that in Ruter's context as well. So what we started to investigate, we started to look into was like, there are different kind of frauds for Ruter and any kind of organization. And if you talk about frauds, you have an internal fraud. An internal fraud can be anything. It could either be a human error. For example, someone, instead of putting in 100 kroner, put in 1,000 kroner, or I mean, if the value becomes bigger and bigger, there can be a human error on the amount of zeros you put at end of the invoice. So that's not considered a fraud. That's just considered a human error. But there can be another thing like there can actually be a fraud. Someone identifies a trend and they start sending wrong invoices, and someone higher up the chain is not paying attention and they approve the invoices. So that's an internal fraud. But the internal fraud is hard to catch because you need to have data to be able to identify, all right, if you're going to make an algorithm using artificial intelligence, we need data. And this case, which came in the newspaper, this was special because you had the data. The police were able to identify special trends, and then they were able to catch the person. But we in Ruter don't have any kind of data, so we don't even know if there's a fraud. So this was just a hypothesis for us. This could happen. But we do know that there's external fraud. And external fraud is kind of easier to look into because external fraud is something which is not specific to Ruter, but it's specific to a lot of organizations. So a lot of companies who have users who use their services, a very small portion or fraction of those users can, in theory, commit fraud for those organizations. And that kind of fraud was also, so if you talk about Ruter's apps and trying to make an algorithm on the app, that is a hard thing. But if you if you look at it from another angle, we are humans, right? We talk with others, we try to share our ideas. And if a person is planning to commit fraud or has already committed fraud, that person might talk to someone else regarding their ideas and share their ideas. And what we investigated was, like, there are forums, online forums, where people can talk about these kind of things. So you have forums online available on the internet. So you talk about Facebook, you talk about Twitter. Then you have some forums where people just go and talk about normal things. And then you have darknet forums as well. Now, darknet forums is a different kind of domain because that's people relate darknet activity mostly with illegal activity, but that's wrong because darknet is an alternate version of the internet, and you can do a lot of interesting stuff over there as well. But people find it easier to open up on the darknet forums because you are anonymous over there. So what we were thinking was, how about we try to scrap all this data? We scrap data from Facebook, we scrap data from Twitter, all the social media forums. We go to Norwegian-speaking forums, we scrap all the data from those forums, and we go to darknet forums, and we try to scrap all this data. Now, we already have the system in place, right? We have the customer insights system. We just have to scrap more data and feed it to the same algorithms. Now, if you use this data and you feed it to the algorithms, what you can do is you can identify what people are talking about. So in real time, you can see like people are, so for Ruter's perspective, we can use the same use case we have. We can see people talking about the bus being warm, the bus being cold, those simple issues. And then we can also look at people talking about fraud cases on the dark web or on special forums. And if you're able to collect that data for what people are doing right now, or people have spoken for some time, you can also use AI to predict what kind of fraud will happen in the future. And this is where it becomes a bit more interesting, and it creates problems for us as well, because when you collect this much data, you can also theoretically say that you know the identity of a person. And that's where GDPR violation and data tilsine violation comes in. And we're not allowed to do this. So even though this was a very interesting use case, we could not work on this because we realized that we will soon be able to start collecting a lot of data. And a lot of that data could also have some personal information in it. But think for a second, like if you are allowed to collect all that data, you actually have a monitoring system in place. So you can monitor a lot of people on the internet and on the dark web. And you can actually figure out in real time what people are talking about. And you can also predict what kind of activity can go wrong in the future. And I think this kind of solution might be mostly relevant for security companies or defense companies, or Crypos, for example, for Schware, who might probably have these systems in place. But the reason why I highlighted this was that this is not a hard system to build. If you keep the data regulations in check and you make sure that you do not collect any personal information, you actually have a functioning system which can highlight fraud for you even before it happens. For legal reasons, we could not go forward and work on this project, but this is a very nice use case which I think any company should investigate into. So that was it from my side. Thank you so much for the invitation, and over to you, Anna and Eric, and thank you for having me.